Ladies and gentlemen of the mental man, today we stand in the presence of an exquisite specimen of a silicon-based electron transportation device, also peasantly known by the average Homo sapiens as a electronics. And what can it do? Regarde. Ambrósio. Luzes. Mais. 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 Menos. Menos. Desligar. Ah, I know. It turns on a light. So what? Well, when it comes to electronics, if you can turn on an LED, you can turn on anything. I mean, your TV, your toaster, your car, your land-to-land missile, and sometimes even your wife. Now, if you have two or even one eye, you might be able to resolve that this is comprised of three main parts. It's ugly, I know, but it works. This guy here, it's a geeetech voice recognition module, which you can get on eBay, blah blah blah. It's cheap, it works. This is an Arduino. If you don't know what this is, you should. You really should learn this guy. And this is just the guy who turns stuff on and off. Why? Because this guy cannot output enough current or voltage to light up strong LEDs like these guys down here, or even I don't know, some 10,000 LEDs I have in my room. First thing you will need to do is to record your voice commands into this guy here, okay? The geeetech voice module. And to learn on how to do that, I will leave a link down or to the side. Yeah. After you recorded your voice inputs into this guy, you will need to run some software on this guy. Why? Because this guy will operate this guy, and this guy will operate the lights. In my case, it could be your car, okay? You can turn on your car, you can open your car, you can close your car, you can open your house, you can close your house. This can do anything, okay? By the way, you cannot program this guy and have this dude connected here to the serial pins. Why? You should know that. Because it will block the communication with USB, okay? Easy. Also, Mr. geeetech voice recognition module here is advertised as having memory for 15 voice commands, which is true, but the memory is spread throughout 3 memory banks, and on each memory bank you can get 5 voice commands. Okay, very simple. Now, what's the problem? You will need to switch memory banks if you want to use all of your 15 voice commands, and it is a bit sluggish, slowish. Yeah, changing memory banks doesn't really work. Okay, so I use only one memory bank, 5 voice commands, and this works awesome. To connect your geeetech voice recognition module to your Arduino, you will go with 4 wires: the ground wire, the voltage wire, and 2 data wires, TX and RX. Okay, the TX goes on the RX and the RX goes on the TX. Oh, no, fuck, sorry. Yeah, you get it. This TX goes into this RX and this TX goes into this RX. I set it up so it needs a wake-up call to prevent false triggering. Then I will control these 2 transoids with pin 5 and 6. Why am I using 2? Because this way I can control 2 different sets of lights. Here we have 2 very small optocouplers. Why? Because this guy works at 5 volts and my lights work at 24 volts. Okay, so these guys isolate one circuit from the other. And how I am dimming my lights is with the PWM function on pin 5 and 6. What's PWM?
Pulse width modulation. Sounds so complicated, and it is so simple.
Why would you want that? Because that's how you dim an LED light. I'll show you. Ambrósio. Luzes. You see, the light is very dim. And why is it? Because the light is staying on for a very small amount of time compared to how long it is turned off. So it's on here and it goes off for a long amount of time. Goes on, click, off for a long amount of time. Long is relative, okay? Because this is doing that at 1000 times a second in this case. So let me show. Ambrósio. Luzes. Mais. Mais. Mais.
As you see, now it's turned on for a longer amount of time compared to how long it stays off. Yeah? And that is with pulse width modulation. Okay? It's easy. You modulate a pulse, how long it's on or off. That is it. That is how you control, in most cases, LED lights and a whole bunch of other things.
Now the software, as you can, oh god, oh my god, oh Jesus Christ, oh. Yeah, it's gotta be done. So yeah, here we have our variables. What are variables? Are values which will be changing further on. So sir will further on be something other than 0. Intensidad will be something other than 20, okay? Byte means I'm going to store a very small value in these variables, and unsigned long means I will be storing very large values, okay? So this reserves more memory in the chip. Now serial begin, this will start serial communication between the geeetech and the Arduino. We set pin 5, 6 and 12 as outputs. This is going to be the pin which will light up my small LED when I wake up Ambrosio, and these 2 pins will control my lights via the PWM function. I gave it another 2.5 seconds, this is milliseconds, for the geeetech voice module to start. Then I'm at serial write, so I'm going to send a signal to the geeetech voice module, and that's going to be this signal here, okay? This will set the geeetech to waiting mode, so it will be listening for more commands. Give it another 1.5 seconds and tell it some more stuff to do, and this will set it up to compact mode. So now when I talk to my geeetech voice module, it will answer with one of these kind of codes, yeah, 0x something something. This will run only once, okay? You start the program and it goes like this, and that stops here. Then it has a loop, and this is the meat of the whole program. This is going from up, down, up, down, out. This is going to check if the geeetech is trying to say something to my Arduino. So if I go Ambrosio, the geeetech is going to say something to my Arduino, and that's this here, okay? So when I go Ambrosio, the geeetech will send my Arduino this value, 0x11. This checks if there is data coming from the voice module, and if there is, it's going to attribute this variable whatever the geeetech is saying. So I go Ambrosio and the geeetech says 0x11, so command will equal 0x11. Then while command equals 0x11, which it does because I called Ambrosio, it's going to do this stuff here. If I haven't called Ambrosio, this is going to continuously be checking for me to say something to it. Actually, it's going to be checking for me to call Ambrosio. If I have called Ambrosio, so command will equal 0x11, we are going to set sir to 1. So if sir equals 0, which it does, as you can see up in here, sir equals 0, sir plus plus, this is going to add 1 to my variable, and it's going to turn my pin 12, which is the small LED pin, high. Okay, so it's going to light up my small LED, and I will know that Ambrosio is now listening to further commands. This variable here is now going to be attributed a value, okay? And that value is how many milliseconds have elapsed since I started my Arduino. So it's always going to be a large sum of milliseconds. So it's going to be a very large value, sorry. And this is going to do that only once, because sir is now 1. And this will only execute this loop if sir equals 0. This, again, is going to check if there is data incoming from the geeetech. And if there is data incoming, instruction will equal that data, okay? So, whenever I go lose, the geeetech will send this piece of command here. Piece of data, sorry. So, instruction is going to be equal to 0x12. If I say luz, if I say something else, for instance, mais, I can say mais, and when I say mais, the geeetech is going to send this, but this is not going to execute because we need this to execute the next stuff. If whatever the geeetech sends to the Arduino is this,
0x12, which is my luz command. So I go Ambrosio, luz. So my instruction now equals 0x12. And if that's true, if instruction equal 0x12, we are going to do this stuff in here. If it does not equal 0x12, this is going to check time again, okay? And it's going to run this small function, which is just going to compare this value here to this value here. So if you remember, this is when I called Ambrosio, and this is just the current time. So this is going to check, this is going to check if the difference between these two variables is greater than 5,000, which means 5,000 milliseconds, which means 5 seconds. In other words, when I wake up Ambrosio, I have 5 seconds to give it the instruction luz. Otherwise, Ambrosio goes back to sleep. It goes command equals nothing, sir minus minus, which means sir will be equal to 0 again, and digital write 12 goes low. My LED goes low. But if indeed I go and say luz, we're going to execute this guy here. Sorry, I just changed this here for basically no reason, whatever. So if intensidad, which means intensity, okay, intensidad is this variable here, and its default value is 20, okay, when the program starts, this variable equals 20, okay. So we come back here. If intensity is smaller than or equal 100, we're going to set pin 5 high and pin 6 high. What this is going to do is it's going to turn my lights on, all of them on at maximum power. It's going to wait 0.1 seconds, and then it's going to dim my lights to whatever value intensidad is at. In our case, it's going to be 20 because we just started the program, okay? But imagine we were with our lights full on, and when I call lights, the luz function, I want to know that the Arduino acknowledged the function. That's why I have this, okay? So it cannot blink the lights any higher because it will be at maximum. So it's going to turn off the lights for 0.1 seconds. Okay, this is just going to blink the lights, fine, whatever. This variable here is going to mark the time when I called this function, okay, the lights function, because I only want this function to be active for 10 seconds. Very well. Light formation equals 1, instruction equals 0. Okay, I just reset the instruction. And command equals 0. I reset the command variable. Now I went Ambrosio, luz. So now I have permission to change my light states. So while light permission equals 1, which is now true, we are going to do all of this. Not all of this, some of that. We have a multiple choice in here. Checks again for serial data, and instruction, which is now 0 because we reset it, will equal whatever comes from the serial. Again, like here, like in here. So it's going to equal either this, or this. It can equal other stuff, but it's not going to do anything. Order and milli, so this is the same story as before. This here is going to check this value against this value here, okay, like before we had a 5-second margin to call the luz function. Now we have a 10-second margin to do whatever we want with our lights. Turn them up, turn them down, and turn them off. We have 10 seconds to do whatever we want to do. Now we're going to have a switch case function. What's this? It's an if statement with multiple choice. So if this is true, do this. Or if this is true, do that. Or if this is true, do this. Okay, this is looks a bit complicated, but it's just, yeah, it's simple. So if intensidad equals 1, it's going to set my intensidad up to 20, okay? And light the lights up to this value and reset the instruction variable to 0, because I might want more light or less light after. But if, for instance, intensidad is at 20, it's going to be now 50, and this is going to write on the PWM function my intensity. Very easy. But if my intensity is already at maximum, which means my lights will be on maximum output, this is just going to blink them a couple times. And as you can see here, it's going to let them stay at intensity 200. Yeah, it's going to let them stay at maximum output. Or I can go lower with less lights. So if intensidad equals 20, it's going to 1. If it equals 50, it's going to 20. If it equals 100, it's going to 50. Yeah. And if it is already in the minimum value, again, it's going to blink my lights. It's going to do this, but in reverse. Or I can turn them off when I go desligar. The geeetech will send this code to my Arduino, and yeah, it will turn off the lights, as you can see here. Analog write, pin 5, 0. Analog write, pin 6, 0. This could be digital write, pin 5, low. It's the same thing. And set intensity to 1. So next time I turn on my lights, they will come as dim as possible. Light permission 0, which will get us out of this loop. Instruction 0, SIR 0, digital write 12, pin 12, which is our LED low, and break. So this is going to reset everything to its initial state. Yeah, it's a bit more complicated than it needs to be probably, but yeah, it works.
And as a result, we get something like this. Ambrosio, luzes, mais, 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 menos, 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 desligar. Bye bye.